Good morning. Welcome for today's chemistry video lecture on synthesis of commonly used drug molecules. Myself KKR Datta from Department of Chemistry, SRM Institute of Science and Technology. Today we'll be discussing about drugs, its introduction and examples, followed by synthesis of aspirin and its uses, and synthesis of paracetamol and its uses. Introduction. Pharmaceuticals form the backbone of modern medical treatment. Most traditional pharmaceuticals are low molecular weight organic compounds. The table shows some of the traditional pharmaceutical substances that are generally produced by direct chemical reactions. The table shows here the type of drugs and the molecular formula followed by its molecular mass and its therapeutic indication, like whether it is used as analgesic or antiviral or anti-inflammatory or anti-ulcer type of treatment. We will be discussing some basic terminologies like drug. Drug is an adsorbed substance that changes physical or physiological function in the body. Medicine, any drug used to cure, prevent, treat illness or discomfort. And depending on the doses, we can have effects whether it can be beneficial or harmful. And there are several forms of drugs in the form of gas, liquid, or solid. And there are again various terminologies like side effects, overdoses, depending on the type of drugs which are being used. Moving further, there are types or formats of medicines like liquid, tablet, capsules, or drops, where in the case of liquids, it is easier to take or better absorbed. In the case of tablet, the active ingredient is generally combined with other substance and pressed into a round or oval solid shapes. In the form of capsules, active part of the medicine which is contained inside a plastic shell that slowly dissolves into the stomach. And in the case of drops, the active part of the medicine works best if it reaches the affected area directly. And inhalers, where active part of the medicine is released under pressure directly into the lungs, followed by injections, different types of injection, in and how, where to be injected, or implants or patches where medicines are absorbed through the skin. Drugs classification. Drugs are categorized in a variety of different ways. In pharmaceutical industry, drugs are grouped according to their chemical activity or conditions that they treat, like allergenics, which reduce allergies, antipyretics, reducing fever, analgesics, reducing pain or also referred as painkillers, anti-malarial drugs, which treat malaria, antibiotics, which inhibit bacterial growth, antiseptics, prevention of germ growth near burns, cuts, and wounds. Along with this, there are other type of drugs which include stimulants, anti-anxiety, sedatives, vaccines, and many more. Now let us discuss about aspirin. Aspirin is the most widely used medication in the world. The following structure of aspirin is shown here. And the chemical name of aspirin is acetyl salicylic acid with a molecular formula of C9H8O4. The name aspirin was derived by combining the letter A from acetyl and spir from spiric acid, which is also called as salicylic acid. Let's take the active ingredient of aspirin, which is salicylic acid, also called as 2-hydroxybenzoic acid. Around 1875 to 1886, salicylic acid and its salts were used for pain relief, fever, and also to treat rheumatism. But it caused gastrointestinal problems and also had unpleasant taste, so its usage was limited. Because of this, chemists sought to improve medicines by synthesizing various compounds containing salicylic acid. Among various derivatives of salicylic acid, acetyl salicylic acid as a pain reliever is a huge success. Felix Hoffmann, a German chemist, was looking for a substitute for sodium salicylate to treat his father's arthritis, during which he came up with the discovery of acetyl salicylic acid. Aspirin is prepared by reacting salicylic acid with acetic anhydride. in acidic conditions, the obtained acetyl salicylic acid along with acetic acid needs to be purified in order to isolate pure acetyl salicylic acid. The obtained aspirin is both an organic ester and an organic acid because of the two functional groups present. The synthesis of aspirin is classified as an esterification reaction. During the chemical reaction, the salicylic acid's hydroxyl group converts into an ester group. The mechanism involves the protonation of carbonyl functional group on the acetic anhydride by sulfuric acid catalyst, thereby inducing a positive charge on the oxygen atom that was protonated. This was followed by the development of partial positive charge on the carbon atom due to the movement of pi electrons between single and double bonds and attraction of electrons towards oxygen atom. Henceforth, the nucleophilicity of the reaction is provided by the lone pair of electrons on the oxygen atom of the salicylic acid's phenol group, forming a tetrahedral intermediate. Finally, the acetate anion will deprotonate the oxygen atom on the carbonyl group on the acetyl salicylide ion to produce aspirin and acetic acid as a byproduct. Now let's discuss the merits and demerits of aspirin. Aspirin original use as an analgesic and antipyretic and to reduce inflammation continues to this day. Aspirin lessens the chance of heart attack as a result of its effect as a blood thinner. The disadvantages of aspirin at overdoses includes it can upset the stomach, where the acidic environment of the stomach, aspirin can diffuse through the protective mucous lining and rupture the cells, causing bleeding. Now we will discuss paracetamol, which is one of the most widely used pain relievers of all ages. Some countries refer paracetamol as acetaminophen and rest they call it as paracetamol. Paracetamol was first prepared by H.N. Morse, an American chemist, in the year 1878. Known as the first to have synthesized paracetamol, but this substance only became widely used as a drug decades after Morse's death. Synthesis of paracetamol starting from phenol is presented in this slide. This method involves nitration of phenol with sodium nitrate, giving rise to mixture of two isomers, namely 2-nitrophenol and 4-nitrophenol. From this mixture, 4-nitrophenol can be easily separated by steam distillation. Hereafter, 4-nitrophenol is reduced to form 4-aminophenol by using sodium borohydride. Finally, the amine is acetylated with acetic anhydride, giving rise to acetaminophen. The mechanism involved in the formation of paracetamol from its precursors like acetic anhydride and 4-aminophenol is presented in this slide. Firstly, the lone pair of electrons on the amine of 4-nitrophenol attacks the C double bond O bond of acetic anhydride, causing its cleavage, followed by nitrogen gets a positive charge but regains electrons by losing a proton. Thereby, the negative charge on the oxygen retains to reform C double bond O bond. Finally, this results the cleavage of C single bond O bond and the formation of amide bond and acetic acid as byproduct. Paracetamol's advantages and disadvantages depending on the doses. The advantages include used for reducing fever in people of all ages and used to relieve mild to moderate pain. The disadvantages include, especially during overdoses, which causes potential fatal liver damage, stomach bleeding when taken chronically. I would like to acknowledge the following portals and books, and last but not least, thank you very much for listening. Thank you.